thank you for this opportunity to present our work that has been done in cooperation with CAREC. And the topic of my presentation is climate change projections and hydrological impact assessment in Central Asia. So the main aim of our project was to estimate precipitation temperature trends in 3 pilot areas in Central Asia. The second one, to estimate and to assess the hydrological impact under climate change, and also to make evaluation of existing and future scenarios of impact on agriculture, and to analyze the existing framework and possible gaps in knowledge in pilot areas in those countries. So in our project we tried to focus on the 3 pilot areas within Kazakhstan, Uzbekistan, Tajikistan, and Kyrgyzstan. 2 of them are river catchments. It's Aspara and Aspara catchments, and also Prevarlia region. Regarding our methodology, the first of all, we tried to focus on different RCPs. It's representative concentration pathways. Then we choose 2 different climate scenarios. It's ISIMI projections and also Cortex projections. For hydrological modeling, we use soil and water integrated model. It's a process-based model that was developed in our institute. And to run this model, we need some input data from pilot areas. After that, after the modeling, we got some results, and based on these results, we make assessment of hydrological impacts and further assessment. So to run our model, it is necessary to have a number of different data. And as far as Central Asia is data scarce region, so we decided to use just global available data. And they are land use data, digital elevation model, soil map, climate data, and river discharge. As far as we didn't have at all climate data, observed climate data, we decided to use reanalysis data. It's Watch Era 40 product. And similar situation we had with discharge data. So we got river discharge just for 1 gauge. It's in Aspara catchment. Regarding the climate scenarios, we decided to use just 2 projections. Cortex from Cortex domain and EasyMIP domain. Both projections are based on SIMI5 simulations, but EasyMIP projections was interpolated to half-degree grid, and after that bias corrected to Watch Era 40 data. So before we started to modeling, we decided to calibrate our model, and here you can see historical period of river discharge and our calibration of the model. So the model was calibrated and validated for historical period, and to estimate how good is our calibration, we decided to use several coefficients. It's Nash-Sutcliffe coefficient and also relative volume error, and both of them is quite good. Regarding the climate projections, we also decided to understand how they're good in this region. So we tried to estimate and compare it to Watch Era 40, and EasyMIP projections shows quite good fitting, but Cortex projections have like a big bias, especially in mountain region. Like in Aspara and Aspara river catchment. So the next one. So regarding the climate projections, you can see here that we try to assess changes in precipitation for Aspara, for Cortex projections and EZME projections on the two RCPs, RCP 2.6, RCP 8.5, and the main conclusion is that we don't see big changes in precipitation in future periods, but multimodal spread is quite high. Regarding the temperature changes, we can see that under RCP 8.5 we have a strong increase, and similar situation with Prearalia region with non-significant changes in precipitation and high changes in temperature with increase up to 6 degrees. The hydrological impacts of projected climate change in Aspara and also further in Ispara catchments. If you look on seasonal changes, you can see that we have increase in from March to May, and some decreases in summer months. And you can see here for Cortex projections, also similar situation for EZME projections. And after our modeling, we decided to also estimate impact and make some analysis of impact on agriculture. So we choose different indicators. These indicators, it's extreme heat events. We try to calculate how many days with temperature higher than 40 degrees will be in the future periods, and also how will change vegetation period in our catchments. So we can say that for both RCPs and for EZME and Cortex projections, we have an increase of vegetation period and also some shifts into 1 month's order. And we can make in general conclusions for the pilot areas that we have no minor trends in the precipitation for all pilot areas. We have a strong increase in the temperature up to 6, even 7 degrees under RCP 8.5. Also, we have a very large multimodal spread in precipitation. And I think it's the most important, and that we have poor quality of Cortex projections, and I think we need to develop a new projections that will be focused on just on Central Asia. And also this normal processes are very important, and temperature increase has a big influence on the catchment and river discharge. And some conclusions for specific areas, but they are quite similar to previous ones, that we have an increase in flow in April, March, and decrease in July and September. In Aspara, the similar trend we have in Ispara for Cortex with increase in March and April, with some rise of extreme heat events. For Prearalia region, we would say that we didn't make modeling, but based on previous studies, we can say that the results are quite similar to Ispara and Aspara catchments. Thank you for your attention.